have sent you the agenda, and you can follow the agenda. We are following the agenda exactly like the file that we've sent you. So next, we are going to have Dr. Ramachandran, the co-investigator, scientific co-investigator of SEAM from Louisiana Tech, and he's going to talk about communication skills for us. Dr. Ramachandran?
Okay.
Hi. So
yeah, I'm here. I'm trying to share my screen. I can't multitask.
Thank you.
Okay, I hope you can see my PowerPoint slide.
Yeah.
You know, put it on slideshow mode. I will make a PDF of these slides, and also I have a small handout. I'll email it to Dr. Guo to be shared with those who are in attendance. Okay, so I assumed that we're going to talk about communicating science because that's the context of our meeting, right? Even though communication skills is a very general thing, I wanted to focus specifically on how we communicate science, and of course that means science and engineering. I'm going to talk about three scenarios. One, you're presenting or you're doing a pitch to a funding agency, or Dr. Kansari mentioned a potential business that maybe you want to support your research. So there is a well-defined approach to that, defined by someone that I will introduce. The next thing I want to talk about is communicating science to the public, which means you may be invited to speak to some audience and their primary concern may not be scientific research. And they may not even understand our concerns that well. So there you have to make some adjustments in how you would normally go about communicating science. The third one I want to talk about, and some of you, when you get further in your career, or maybe even while you are graduate students, may get interviewed by media, either television or print media. And you may want to prepare, do some homework before you subject yourself to that experience. So I'll talk a little bit about that. Okay. So I want to introduce George Heilmeier. He was at the RCA laboratories. He invented the liquid crystal displays that we all use pretty much all the time. We don't use calculators that much anymore, but we have other forms of LCDs all around us. He was the director of DARPA for a few years. The next slide, I'll show you how long he was at DARPA. Then he retired, became the vice president and chief technology officer for Texas Instruments in Dallas. And then he retired from Texas Instruments and became the CEO of Bellcore, which was a big company. So while he was at DARPA, so here you see the time that he was at DARPA, 71 to 75, he was the assistant director, and then he was made the director in 75, and he served as the director for 2 years. He created this so-called Catechism. I don't know who named it. Catechism really stands for religious education, especially for Catholics. I don't know who named it the Heilmeier Catechism, but that's how it is known. And if you search for Heilmeier Catechism on Google, you will see a lot of different slides of containing basically what I'm about to present to you. Okay, so Heilmeier's idea was, if you come before DARPA and ask for money, you got to address the following questions. What are you trying to do? Articulate your objectives using absolutely no jargon. And that last part is very important because not everybody in the room is going to be a specialist in your area. Most of the time, nobody in the room is a specialist in your area, okay? They come there because they have some familiarity with the general area that you are working in, but that doesn't mean they know everything about it. And when you write a proposal, you want to make sure your proposal introduction, the abstract, which is usually the first thing reviewers read, You want to make that as friendly as possible, devoid of technical jargon. Okay. Then you have to answer the question of how is it done today? What are the limits of current practice? Obviously, you're assuming that you're trying to improve on something. Now, if you're going to come and propose something like time travel, you can easily answer the second question, saying it's not done today. Okay. What's new in your approach? So how are you going to improve on how it's done today? Why do you think it'll be successful? You have to have some reason to think that you might actually succeed. And this is a big kicker. Who cares? So if you're successful, what difference will it make? What impact, meaning impact on society, impact on science, impact on technology, what impact will success have? And the second part of this question is extremely important. How will it be measured? You tell the sponsoring agency that if we succeed, I mean, this is how we're going to measure whether we succeed. Okay. What are the risks? You have to think about that. Even though you think it'll be successful, you may not succeed in the first time. So you may have to take longer to finish this project than you had initially thought. And you have to anticipate why might you not succeed. When we prepared the strategic plan for SIM, we had to provide possible risks and also a risk mitigation plan. That's what this is all about. How much will it cost? How long will it take? What are the midterm and final exams to check for success? Meaning, halfway through the project, how would you know you're still on track and you are likely to get to the finish line? And once again, second time, how will it be measured? So measuring your progress clearly is extremely important to funding agencies. Now, DARPA funds a lot of high risk research, and they may fund something even if they're not fully convinced it's going to succeed. In fact, a lot of the projects they fund do not succeed. They just decide to take a chance because they have faith in the researcher, or the researcher comes before them and makes an absolutely spectacular pitch. Okay, it's a skill we have to cultivate. Also, it's a skill that does not come automatically to most of us and takes hard work on our part before we show ourselves in front of a panel or write a proposal to get money from a funding agency. Okay, let's talk a little bit about communicating science to the public. And when I say public, I'm talking about going in front of a high school class to talk about your research, which actually is not a bad thing, because high school students often do understand a lot of what we have to say if we frame it in the right way. I had a very interesting experience of speaking to the Ruston Rotary Club before the pandemic, and that was a very strange experience. This is a group of people that used to meet once a month, and they look around the community for someone to talk to them about anything. And so I had to be very careful in how I presented the whatever I came to talk about, and I'll show you how I approached it. Okay, so first thing to note when you talk to the public, focus on the outcomes. Most of us, just think about this: someone you meet on the street, on your campus, or your friends say, "Hey, what are you doing these days?" We start out by saying what kind of experiments we are doing, what kind of calculations we are doing. It makes absolutely no sense to someone in the general public who is not steeped in science and technology or in the area that your research is in. So I know Dr. Meng is extremely excited about this aberration-corrected TEM that LSU is planning to purchase. If he starts talking about experiments he hopes to do with that TEM, it won't make any impact on the general public. It kind of perpetuates that stereotype of scientists and engineers that we are all nerds. We don't know how to relate to the real people. Emphasize the benefits of your work. Your clever innovations are secondary. And this is these first two bullets are really hard for us to digest because we are so excited about what we plan to do or what we are doing that we want to talk about that. Unfortunately, if we start by that, you will lose your audience and you don't make any kind of headway. So obviously, most of our work addresses some technology gap, something that needs to be done in order for our field to advance or in order for knowledge to advance. And that technology gap has to be framed. Obviously, you have to talk about why you're doing the work that you're doing, but it has to be framed in the right way. And it needs to, ideally, you would put it in a way that's easily relatable. And in order to do that, you need to know a little bit about what kind of audience you are talking to. Okay. Preston Rotary Club is mostly business people. So you've got to keep that in mind. Use evocative images to make your points. You can steal images from Google, that's public domain. It doesn't have to be your own images. In fact, I would probably recommend against showing your graphs and charts because, again, public is not prepared to absorb that kind of information, at least not right off the bat. Here's something that most of us need to learn. Do not use your slides as your notes. So this is a big difference from making a technical presentation. The technical presentation, and you're all going to make one today, and I'm really looking forward to hearing that, your presentations and seeing your slides. We put our bullet points on the slide and we essentially talk about the points. When you talk to the public, it's best not to do that. It's best to not use your slides as your notes. So then how do you remember what you have to say? Well, you have to rehearse. You have to come prepared to talk. And this last point, if you communicate one point effectively, and there's a triangle tool that I'll introduce later, it's better. You will leave your audience with some idea of what you're doing or what you came to say than if you communicate it or try to communicate 10 points badly, in which case, they don't remember anything. So those are some of the ideas to keep in mind. So as an illustration of, I'm not saying this is the way to do it, but many of the faculty members attending today and myself, we were all participants in a scientific communication workshop that was held by NSF in 2017 in Baton Rouge. And we had some 3 people who came from DC. They were hired. We had a 2-day, very intense experience on how to communicate science to the public. So what I'm doing or what I'm telling you is more or less, what I learned. So when I talk about the SIM project to a public audience, I would start out, now I'm talking about my research within the SIM project. Obviously, if someone asked me to come and talk about SIM as an overview, I will probably approach it a little bit differently. But my work in SIM has to do with Science and Technology Thrust 1. We collaborate with Dr. Meng's group at LSU, Colin Wick, my colleague at Louisiana Tech, and our students, Miraz and Nisha, who are going to present later today. So we work together with Dr. Meng and his students. So this is how I approached my presentation. And I'm going to present the slides. Maybe I'll stop, interrupt what I'm telling the audience with my own commentary to you, okay? So I would start out by saying metal and alloy-based manufacturing is one of the mainstays of our economy. And I would show this picture, no words at all. It's enough for people to get the idea of what I'm talking about. And I will say that well-established methods exist for metal-based manufacturing at large scales. And I'm showing metal parts everyone recognizes, pieces of a car. However, they fail completely when scaled down to human hair scale. Notice that I'm not going to say micron scale. I could say micron scale, but then I'll have to stop and explain what that means. Okay, but it's much better. Everybody recognizes a human hair scale. And so that should be enough. And the reason that I went from the car slide to this slide first is because I wanted to have some picture that had holes in it at large scale before I introduced holes at the micron scale. So I will obviously say that this is an example of trying to make holes at the human hair scale with a post that is obviously around that size. At this point, I should tell my audience, why do we need these kinds of objects? Why would you even bother making these micron scale holes in metal objects? So I would introduce why we need to make these kinds of tiny devices. And again, use examples that they may recognize or understand. Cooling advanced electronic devices, chemical analysis and oil and gas exploration, wearable poison gas sensing devices for first responders. And on the right-hand side, you will see that I introduced a picture, a credit card-sized chemical analysis device. I did not call it a gas chromatograph. I know that would be too much. So chemical analysis device, good enough, all right? And when I'm talking to the audience, I'll point out that compare that to the big box sitting behind it, which is how it's currently done. Okay. So what's the solution? And I'll say we want to go from this picture on the left, which the audience has already seen, to what you see on the right-hand side. And this is what we do. Now, obviously, that's not entirely true. Dr. Meng's students are saying, wait, this is our research. Yes, it is. After I present this slide, I will say, okay, so you have the posts are coated with aluminum oxides or nitrides, and I will have to probably spend a little bit of time explaining what that is. I might talk about rust as an introduction to metal oxides. And then I will talk about what we do, which is all computation. So you kind of have to bring your audience along. You cannot expect them to understand what even a ceramic is or a gas chromatograph is. Okay? So that's just my, what shall I say, clumsy way of talking about science without introducing technological jargon. Media interviews. This is an interesting thing. And I said with a slightly confrontational reporter, most of us won't confront reporters that are hostile unless you happen to work in areas like climate change. Then it could get political really fast. But any media interview is a potential opportunity, but also a potential danger. So what we were told by our coaches in this workshop was, someone will usually call up and say, hey, Professor so-and-so, can you talk to us about whatever? And there may have been some incident in the community, and someone mentioned you as an expert. Whether or not you're an expert, they're calling you with the impression that you know something about this topic. Or you had a major success in a grant, like SIM, and they call you to find out more so they can write a story. Okay. Now they want to frame it in a way that the public will be interested. So the advice that we were given is never get into the interview right off the bat. They call you up, always make an excuse. Say that, can I get back to you? I'm about to go to a meeting. Or, oh, I'm really sorry. I can only talk to you later this afternoon. You can always say that. But in the same time, you ask the reporter, what is it that you're covering? What's your angle? What's the story? Why did you call me? What kind of expertise am I bringing to the story? And they will tell you, because they want your cooperation. Even if this is ultimately they're planning a hostile story, they still need you to cooperate. Okay. So they will usually tell you what it's about. And then you prepare your communication strategy, which one of the ways you communicate is using the so-called message triangle. Okay. Now, you don't have to draw a triangle and do this, but it helps to organize your thoughts. So the main message goes in the middle of the triangle. What do you want people to do or remember after you're done? Usually, if it's a TV interview, you will only get a minute, maybe less than a minute. So you want to make sure that this message gets communicated. The three corners of the triangle, you want to write down your key talking point, and you might want to prepare something to back it up in case the reporter asks you. Or usually when people assert something, it's better to back it up by saying, for example, or as you can see, you provide the point that proves what you just made, or the point that you just made. Again, key talking point number 2 and something to back it up. Key talking point 3 and something to back it up. So as an example, I made up the following scenario. Oh, excuse me, I have this box here. So you want to come prepared with your message. You want to deflect questions or use them to move to the points you want to convey. Generally, you don't want to ignore the question. You want to acknowledge that you heard the question, because if you ignore the question, that reporter is going to ask again or may ask again. And it could get to be, the interview may get unnecessarily confrontational, even if you didn't mean it to become. And you don't hesitate to repeat your key talking points, ideally with new proof points. So you're building your case over and over, but the key talking points keep getting repeated because people have short memories. Most people are not paying full attention to the TV or even reading the newspaper anyway. And you want to also touch on the main message at every opportunity you get. Again, if you keep returning to it over and over, that may stay with the people. Now, before I go to the next slide, I just want to point out that when you listen to politicians talking, getting interviewed, politicians, successful politicians, generally get better at this as they go. They have to, they have no choice. And they also have media staff who train them or coach them, saying, oh, that interview went terribly badly, next time do this. And so they will get advice on how to approach things. And some people cannot be coached. When they talk to the press, all their staff members are cringing in the corners, hoping for the best. A good example being our fearless leader, Donald Trump. When he talks to the media, all bets are off. But on the other hand, if you listen to Vice President Pence, now there is a skilled communicator. You may not like anything he has to say, but he makes his points. So when he's confronted with the criticisms of the federal government's response to the coronavirus, he keeps repeating, we are testing more people than any other country in the world. We flattened the curve, we saved lives, even though 136,000 people are dead right now, and that number keeps climbing. You listen to him. Even yesterday in Baton Rouge, he made that same point. We saved lives. That's what he came to say, and that's what he's going to say. Okay. Another person that I'm not a big fan of his politics, but I admire the way he talks to the press, is Ted Cruz from Texas. Ted Cruz was a debater in high school and college, and it shows. He is very skillful at deflecting questions. One incident that especially stuck with me was there was a point during the 2016 Republican primary. So this is before the election where they selected their candidate to run for president. There was an incident where Donald Trump criticized Ted Cruz, in fact, called his dad a murderer and called his wife ugly. And of course, Ted Cruz was outraged, and he expressed his outrage in the media. But after Trump became the Republican nominee, Ted Cruz was a big supporter. He came on board, he did fundraisers for Trump. And of course, the media asked him, how can you do that? He called your dad a murderer and your wife ugly. And the response was absolutely spectacular. Of course, Ted Cruz could have gotten into it or say ignored it, but he didn't. He said, that is exactly what the liberal media want to do. They want to sow discord in our party. I'm here to support our presidential candidate. And I thought, wow, that was skillful. He didn't take the bait. And that's something rarely do we have to do that in science, but it's something we need to keep in mind, that reporters need a story, and the more sensational that story is, the more they like it. And so don't take the bait. Come prepared. So I made up this following scenario. Let's say that somebody in their foolishness decide to put me up to defend the high performance computing in Louisiana. I'm on the Lawney Management Council. And so our high performance computing capabilities are critical for the state. That's my central message. Now, I could talk about that. Oh, I'm a computational material scientist, and look at all the wonderful things we can do. If I'm addressing the legislature, or let's say a block of lobbyists or voters that I need to win over, talking about computational material science won't do anything. So my key talking point number one, so this is what I want people to remember. Louisiana's high performance computing capabilities are critical for the state. Talking point number one, our lives rely on high performance computing in ways that we may not even realize. So I'm telling the public that you are depending on computing right now and you may not even know it. So for example, computational models are used to predict the weather every day. Those pictures on your TV during the weather forecast, they don't materialize by magic. They have to be developed from weather models, especially when severe weather hits. You know, when we have thunderstorms, tornadoes, hurricanes, it saves lives and money. And this is an especially good point to make in Louisiana because everybody relates to severe weather in the state. Key talking point number two, modern supercomputers are able to do very complicated calculations in a short time. And my proof for that is tropical storm tracks are now updated every 20 to 30 minutes instead of hours. And that is a change that has taken place within the last 10 years. When Hurricane Bob, I was a postdoctoral fellow in Texas 30 years ago when Hurricane Bob hit, and the tropical storm updates or the hurricane track updates were provided twice a day. And the rest of the time, the computers just cranked away at full speed and tried to come up with the predictions. Models were bad. Computers were slow in comparison to today's computers. So tornado track predictions, if you have a tornado warning and you're watching the Weather Channel, those tornado track predictions are updated almost in real time. They get radar data and satellite data and the computers generate the predictions. And it's impressive how quickly they're able to do that. Talking point number three, computational research is faster, safer, and cheaper than experimentation. Again, I would go back to something that people can relate to. For cities like New Orleans, a large number of hurricane scenarios can be modeled on computers quickly so that effective disaster mitigation strategies can be developed without disrupting lives or businesses. And again, something people can recognize. Let's say bad weather is coming, a hurricane is approaching Baton Rouge. Now, Baton Rouge is a city that floods fairly easily, many parts of Baton Rouge. And let's say the only option we have to figure out what's the best way to evacuate the city is to have everybody pack up and first go up I-10 to the east or west, or go up 110 to the north. And let's say, okay, Tuesday and Thursday, we're going to do the I-10 option, and Monday and Wednesday, we are going to do the 110 option. Everybody pack up, let's go. Boy, that would be a huge disruption. But we can model this on a computer and see which one works out better. So this is an example of how I would develop my communication strategy. And I'll come prepared with this. Whether or not I actually draw a triangle, well, that's up to me, and you should decide whether it's useful to you. But this is I just wanted to give you a couple of examples of how to approach communication outside of science. I think you've all seen plenty of scientific talks. So, and you probably know the do's and don'ts. You recognize from the seminars you've attended, you know who the good speakers are and who the bad speakers are. My advice to you is pay careful attention to the good speakers, see what they do well, and try to emulate what they do. That's basically, that has been my strategy in scientific communication. Okay, that's what I had to say. I'll be happy to, I don't know if I can answer questions, but I'd love to hear your comments. Okay.
Yeah, thank you. Thank you, Dr. Ramachandran. Does anybody have any questions? So if you have any questions, please unmute yourself and ask the question. So it seems no one has any questions. Okay. I really like the role-playing part of your presentation. Thank you. It was really good. It was really useful for me. So,
all right, I'm glad. I will send these slides, and I have a kind of an information packet that includes that triangle. I'll send that out. Okay.
That's great. We will send it.
Thank you for letting me talk to you all. I'll stick around. That's my plan.
Thank you. Thank you so much.